A key technique to construct geological timelines is radiometric dating, a method to date geologic materials by measuring the presence of radioactive isotopes in a sample. The makeup of geologic materials revealed by radiometric dating also indicates how the rocks were formed, which provides us with information about the climate of the past to prepare for the future. I'm Rachel Kazarian, and I will show how rock samples from South Asia, West Africa, and South America reveal climate change events through radiometric dating analysis conducted by research teams in these regions. We are looking at a variety of rock types and samples from 3 specific regions labeled with circles on the map in Figure 3. First, I will explore how lead and uranium radiometric dates for the sandstone show the events that form the Chittagong-Tripura belt fold in Bangladesh, South Asia, and their climatic results. Next, I will explain how new data from radiometric dating of lead and uranium from rocks in the Yarra Bubba impact structure coincides with global climate change in Western Australia. Lastly, we go west to Argentina and South America and construct a faunal timeline with new radiometric argon samples. The Chittagong-Tripura beltfold is an active fault in the Indo-Burma Range in Bangladesh. Considering seismic activity poses a concern for millions of people living there, it is important to gather climate information to explain the past to prepare for the future. In a 2020 Gondwana research study, M. Julail Jalaler Rahman and others measured isotopic concentration ratios of lead and uranium in zircons from sandstone samples using the Glitter 4.0 at the Institute of Geology and Geophysics at the Chinese Academy of Science in Beijing. The geochemical compositions of sandstone is used to infer tectonic settings of the fold belt, specifically transpression tectonic events such as the folding in the Eastern Basin in the Dauki Fault. These events deposited sediments in the Taipan-Dupi-Tila Formation in the Chittagong-Tripura Fold Belt. Comprehending the tectonic shifts that formed the belt is important because increasing activity would put more people at risk of facing the potentially detrimental consequences of climate change. The Yarra Bubba impact structure is the eroded remnants of an impact crater located in the Yilgarn Craton in Western Australia, and it is considered the oldest known impact structure on Earth by radiometric data. Figure 5 shows the map of the impact structure, as well as 2 samples of the locations, 14YB03 and 14YB07, used in the analysis from a 2020 research report to recognize Yarra Bubba as the oldest impact structure. Erickson and team measured isotopic concentrations of lead and uranium using the SHRIMP-2 secondary ion mass spectrometer at the John de Laeter Center at Curtis University in Western Australia. The SIMS analysis of zircons from the Yarra Bubba monzogranite yields a weighted mean dating back 2,229 plus or minus 5 million years ago. Figure 6 shows the geologic transitions, impacts events, and the environmental record of the early Paleo-proterozoic Earth, which includes the Yarra Bubba impact. Research points to the Yarra Bubba impact overlapping with the end of glacial conditions of the Paleo-proterozoic. This analysis illustrates that meteoric impacts can have significant consequences on the climate around the world. The fossil record of the Pampean region of Argentina has long been constructed using a chronostratigraphical scale for the late Neogene sequence of Buenos Aires province. In a 2021 research article, Provosti and other researchers determined radiometric measurements of argon and escoria rocks from the Argentinian Atlantic coast. The results of the study used the radiometric data and existing biochronology to refine the faunal record of the Pampean region. The circled faunal assemblages in Figure 7 were radiometrically dated and coincide with the increase in faunal turnover, decreasing temperatures, glacial activity, and meteorological contact with Earth's surface during the Pliocene. Specifically, faunal turnover in the late Neogene is associated with the effects of global climate change. Climate change does not only affect the environment, but all the organisms that interact with it. Radiometric dating helps us find out more about Earth's historic organisms and the environmental conditions in which they lived. Radiometric dating is considered very reliable for determining the age of geological samples, which is why it is an important technique for paleo-proxy record. While there is a list of elemental isotopes to explore in radiometric dating, the samples used in the research analysis were identified as the decay of lead and uranium and sandstone in crater rock samples and decaying argon in escorias. We looked at 3 different geological sites: the Chittagong-Tripura Fold Belt showing tectonic events, the Yarrabubba impact structure showing meteorological effects, and multidisciplinary cross-referencing in the Pampean region showing the faunal impact of climate change at given points in Earth's history. In conclusion, radiometric dating helps us understand the impact of different geological events of Earth's climate. Thank you for listening.